Hey, geometry. We are in Unit 4. We're going to do Lesson 4, still talking right triangles, and we're going to dive into the ratios of what makes right triangles so important in what we do. So, our little warm-up. Consider A over C, so that is my short leg over my hypotenuse, and B over D, my short leg over my hypotenuse. Which is greater, or are they equal? Explain how you know. What do we know about these triangles? We've got no information about these triangles other than I have two angles equal to each other. Therefore, we know they are similar. Now, what do we know about similar triangles? Okay, back in Lesson 1, we set up all of our congruency statements, and we would say, I don't know, let's call this big angle A and big angle B. We would say angle A is congruent to angle B. I'm not labeling these very well. We could say angle C is congruent to angle D. And we could say our third angle is congruent to A, B, C, D, E. Angle E is congruent to angle F because it's the third side and all the angles inside a triangle add to 180. So we know these triangles are similar. We know the angles are congruent. We also therefore know that the sides are equal. The ratio, the proportionality of the sides are equal. I'm not saying that correctly. Back in Lesson 1, we said that AE over BF is equal to AC over BD is equal to EB over FD. Those proportions are equal because the triangles are similar. So I used the two-letter segment names. We can use the one-letter segment names of A over B is equal to C over D. All right? So we can't say which one is greater. We know this triangle is bigger than that triangle, but the proportions are equal. The measurement of A divided by B is equal to the measurement of C divided by D because the triangles are similar. Okay, moving on. Tons of triangles. All right, so I've got some triangles here on my desk. I've got angles, written here. Draw several right triangles using the angles you receive. Okay, we're going to open up GeoGebra and do that. Precisely measure the side length of the triangles, and we'll do that also in GeoGebra. And then complete the tables by computing 3 quotients for the acute angles in each triangle. All right, so let's hold off on this. All right, I'm going to push pause and grab our materials. I'll be right back. All right, this is going to be interesting. So if you go to your curriculum and you go to the student lesson, there's an applet, and you can play along with me. And that's what I would recommend you doing because you're going to get a little more out of it. But I'm going to go ahead and work through, and it says that your teacher will give you some angles. The angles we're going to deal with, let me move this over. That'll be okay. Not perfect. I don't know if I can move it over any further. Bummer. Oh, we can just hide it though. Cool. All right, this will be better. So we're going to be using draw pen. Okay, let's see. $10 degrees. Let's just do every other. A small one. Let's do 30 degrees, 50 degrees, 70 degrees. Let's just hold off on those for a minute and we'll get to, you'll understand where all this is connecting to. So draw several right triangles using the angles you receive. So move the slider to change the angles. Point A will change the size. So let's do 10 degrees first. Okay, so 10 degrees. And it says complete the tables that you have in your classwork by computing 3 quotients for the acute angles in each triangle. So first we're going to do the length of the leg adjacent to the angle divided by the length of the hypotenuse. So adjacent to the angle is our long leg. So this is A, and it is, excuse me, 16.04 divided by the hypotenuse, 16.29. 16.04 divided by 16.29 gives me 0.98. Let's do 3 decimal places. And then the length of the leg opposite of your angle divided by the hypotenuse. So this is the opposite one. So we want 2.83 divided by the hypotenuse again, 16.29. 2.83 divided by 16.29 gives me 0.174. And then C, the length of the leg opposite from your angle divided by the length of the leg adjacent. So this is my angle. Opposite of the angle is 2.83. Adjacent is 16.04. So we want 2.83 divided by 16.04. 2.83 divided by 16.04. And that gives me 0.176. All right, those are ratios. Okay, those ratios are important. Yep. So let's do another angle. Let's just go straight for the 50-degree one. So I'm going to move the slider and change it to 50. Okay, we're going to do the same calculations with the new measurements. First, we're going to do A is adjacent, so that's 10.47 over hypotenuse. Well, that hypotenuse hasn't changed, has it? And the next calculation, I'm just going to write them down now, is opposite. So 12.48 over 16.29. And then opposite over adjacent. 12.48 over 10.47. So let's do some math. This one is 0.643. 12.48 divided by 16.766. And 12.48 divided by 10.47. 1.192. Okay, I'm going to pause there. I don't think we're going to get much. So these are the 2 that we calculated. All right, so hold on a second. There we go. Okay, I want you to stick with me because this is important. I'm going to change colors. See how I just changed the triangle? I just want to move this whole thing over. It's not moving over well. I made my hypotenuse bigger. So if we look here, my hypotenuse did not change for the 10 degree or the 30 degree. So I want to change my hypotenuse. So I just drug that point A a little bit so I could change my hypotenuse. So let's do green, and I'm going to do 10 degrees and 30 degrees again. All right, so did we do 50? Oh, I'm so sorry. This is when I lose students. You guys are like, dude, she doesn't know what she's doing. Okay, these were all 50. So these are all going to be 50. We're going to do the same ratio. And I'm actually going to need more space. So let's just go ahead and move that down. All right, so let's write our ratios for the 50 degree. So we have a new hypotenuse. So A was adjacent over hypotenuse. So we're doing 14.93 over 23.22. And then we're going to do opposite, 17.79 over 23.22. And then we're going to do opposite over adjacent, 17.79 over 14.93. Handy dandy calculator, 14.93 divided by 23.22. 0.643. What? Next, 17.79 divided by 23.22. 0.766. What? 17.79 divided by 14.93. 1.192. What? Okay, I changed the size of my triangle, but all the angles stayed the same. And the ratios of adjacent hypotenuse, opposite adjacent didn't change. The ratio stayed the same, okay, because the triangles are similar. Let's do the 10. I know you already know the answers, but we're going to do it. All right, so my hypotenuse is different from my first round. So let's go ahead and write in my values. So adjacent, 22.87 over 23.22. Opposite, 4.03 over 23.22. And then opposite over adjacent, 4.03 over 22.87. So let's do those ratios. And that is 0.985. Cool. 4.03 divided by 23.22. 0.174. 4.03 divided by 22.87. And that is 0.176. The ratio didn't change. Those ratios are congruent, which was our guess in our warm-up. And trust me, no matter what angle we choose, and if we change the size of A, it's going to be the same, okay? It's really cool. Find the mean of each quotient. That means that we're going to add together this. Oh, I want red. We would add together this and that and find the mean of the two 10-degree triangles, and this one, and this one, and this one, oh, and that one, and that one. But ours were exact because we're using a computer to measure for us. We're not using our own straight edge because that wouldn't be pretty. We'd get little wonky answers and it'd be fine. So that last thing where it says find the mean of each quotient, that means that we're averaging those values. But our values are exactly the same, so we're cool. What do you notice? What do you not wonder? They're the same, okay? That's what we notice and wonder. It's very, very cool. All right. Compare the row for 20 degrees and the row for 70 degrees in the right triangle table. What is the same? What is different? So hold on a second. I'm going to pull a table in here for us to look at. All right, so give me a second. So if you look at this table, let's see. This table right here is all of the angles. We only did the 10-degree one and the 50-degree one. So if you notice, these are the values we got: 0.985, 0.174, 0.176, and then 0.643, 0.766, and 1.192. Those are the values we got. If we had a classroom full of people, we'd have some people working on the 20-degree angle, the 30-degree angle, etc., etc., etc. And we'd fill out this table. And this table is going to be very useful for us. I will link, let me make a note, I will link a table in your Google Classroom so you can have access to it. Link trig table. I'll forget. I know, I'm sort of crazy like that. Now, the next lesson says this is the teacher book, I know, right here. So here it says to compare the row for 20 degrees and the row for 70 degrees. So let's do that. The row for 20 degrees is 0.940, 0.342, 0.364. And how about the 70 degrees? 0.342, 0.940, and 2.747. Okay? Hold on a second. I need a whiteboard. See if I can. I'm going to shrink that so you can still see it. Yet I want to write on this paper over here. Oh, it's fine. Okay, so we're working on number 1. I can't write over here. It's sort of a bummer. But what's really cool is we can draw. I know it disappears, which I still don't understand. It's not a mistake. What is 70 plus 20? It's 90. Okay? So what about if we compare 30 and 60 degrees? Okay, not a mistake. How about 40 and 50? Not a mistake. All right, adjacent over hypotenuse and opposite over hypotenuse are equal for the two angle measurements that equal 90 degrees because they're the same triangle. All right, if we give a triangle like this, where this is 30, 60, and 90, it's the same as this one. That's a bad drawing. All right, let's try again. 30, 60, 90, and 30, 60, 90. What we name adjacent becomes the opposite. What we name opposite becomes the adjacent. So the problem doesn't change. It's just a little bit different. Let me show you one more thing because we did not talk about opposite over adjacent. So if I look at the 20 degree, opposite over adjacent, that's oop, not op. Opposite over adjacent is 20.364. And then for the 70 degree, opposite over adjacent is 2.747. Well, I said that if we have two triangles, let's say this is the 20 degree, so opposite over adjacent is opposite over adjacent. If I do the same thing, nope. Ugh, I can't draw them, I'm sorry. Opposite, and I did oop again. Sorry. Opposite over adjacent of the 70 degree. Well, this is the 70 degree. So that is adjacent over opposite. It's going to be equal to the 20 degree. Ah, my light just turned off. Opposite over adjacent. All right, hold on, let me turn that back on. I might not have moved enough. This is awful. Okay, so let's just do this. I need my handy dandy calculator. There we go. So we know that these are opposites of each other. So I can do 1 divided by 0.364. It's called the reciprocal, and I get 2.747. 4, 7. Okay? That's called the reciprocal. Reciprocal. I can do the same thing with this one. 1 over 2.747 equals 1 over 2.747 equals 0.364. So this column over here are just reciprocals of each other. So this one and that one, it's flip your fraction. Take one, divide by the number. This one and this one are reciprocals. 2070 are reciprocals. Okay, 3060 reciprocals. 4050 are reciprocals. So these flip this way, and these are reciprocals of each other. And that's not a mistake. That's how the math works, because they're the same triangles. Okay, that was a really long explanation. I hope it made sense to you. And I will copy this table. Oh, there's one more thing, sorry. One second, oh, let's do it here. So here we have the row for 55 degrees is given here. Let's compare it to this one. Complete the row for 35 degrees. Well, we can do that because 55 plus 35 is 90. So this would be 0.189. This would be 0.574. And this would be 1 divided by 1.428. Or 0.700. Okay, so we got that. That's cool. What do you know about a triangle with an adjacent leg to hypotenuse ratio value of 0.893? Let's look over here. We said adjacent hypotenuse, 0.893. It is somewhere between these two values, right? It's approximately 25 degrees. So that's what we know about that one. All right, that's it. I will copy that table and put it in your classroom. And you'll need that for your homework. All right, good job today.